Hello, welcome again. We are solving some questions of production engineering or manufacturing science. The topic is uh, welding or joining processes. Question number 9 is two pipes of inner diameter 100 mm and outer diameter 110 mm, each joined by flash butt welding using 30 volt power supply. At the interface, 1 mm of material melts from each pipe, which has a resistance of 42.2 ohm. If the unit melt energy is 64.4 megajoule per meter cube, then the time required for welding in second is option A 1, option B 5, option C 10, option D 20. So volume of weld is pi by 4 110 square minus 100 square into 2. We are taking one from each side, and this is the outer diameter, this is the inner diameter. So that is the volume of weld. So that is 3298 mm cube. So as they are pipe, so it is cylindrical in shape. So volume of material is or weld is this. Okay. So and the melt energy, so melt energy is given as 64 megajoule per meter cube. Okay. 64.4 megajoule per meter cube. So for the given weld volume, the melt energy is that is the melt energy and that is the volume. So we multiply this, then it will be 211.1 joule, and the energy supplied or heat supplied is here VI. V is 30 volt and resistance is also given, that is 42.2. So I is your V by R, and this is your 0.7109. So Q is your 30 into 0.7109, or it will be 21.327 watt or joule per second. And time required is that is energy required for the melt, and energy available per second is this. So time required is will be divided by 21.327 when we 10 seconds approximately. So answer is option C. Next, question number 10. In arc welding of a butt joint, the welding speed is to be selected such that the highest rate is achieved. The melting efficiency and melt transfer efficiency are 0.5 and 0.7 respectively. The area of weld section is 5 mm square, and unit energy required to melt the metal is 10 joule per mm square per mm cube. If the welding power is 2 kilowatt, the welding speed in mm per second is closest to option A 4, option B 14, option C 24, and option D 34. So power supplied is 2 kilowatt or 200 kilojoule, 2000 kilojoule per second. Uh, that is power is 2000 joule per second. Okay. And the uh, heat per second or power given to weld is we are considering now efficiencies also. That heat transfer efficiency is 0.7 and melting efficiency is 0.5. So the heat given to weld will be 700 joule per second, and heat required for weld per mm cube is 10 joule per mm cube. So as the area is your 5, area of weld section is 5, so heat required is 10 into 5 joule per mm. Okay. So if V is the weld speed, then heat required is 700. Heat required is 10 into 5 into V, because this is joule per mm, and if we multiply by velocity of or weld speed, then it will be joule per second. So now this is your heat required, and this is the heat transferred per second. So equating these two, we can get velocity as 14 mm per second. Okay, so answer is 14 mm per second. Option B.